The population P of a certain city, Y years after the last census, is modeled by the equation below, where R is a constant and P0 is the population when Y equals 0. If during this time the population of the city decreases by a fixed percent per year, which of the following must be true? Recall that every question has a concept behind it. Looking at this equation clues us in that this is an exponential function. And it's talking about a decreasing exponential function. So that means we're looking at a decay function. You will recall that growth or decay is determined by the value of what's between the parentheses. So because we have 1 plus r in here, and it's talking about decreasing, we know decreasing, what's in the parentheses, must be between 0 and 1. So what does that mean? We can take what's inside of those parentheses, which is 1 plus r, and say if you have a decreasing function, 1 plus r must be between 0 and 1 by law. So our goal is simply to solve for r. So we're going to subtract 1 from everything. And on the left side, you'll see we have a negative 1. In the middle, we have an r, and on the right side, we have a 0. So the answer has got to be B. I'm going to take a moment for those who may need to review a little bit more about exponential functions. And I just want to remind you real quickly that exponential functions show up in 3 different forms on the SAT and the ACT. The first one is, the graphical style. Y equals A times B raised to the power of X. The second one is a real world example where A equals P, 1 plus or minus R raised to the power of T. And that's the version that we're looking at on this question. And then last but not least, we've got the geometric sequence version. A sub n equals the first term known as A1 times common ratio, which is the number that you're multiplying each time to get the next digit, raised to the n minus 1. Now, in all of these cases, they really abide by the same rule. The first digit is the initial value. So you can see in this case, A would be the initial value, P would be the initial value, A sub 1 would be the initial value. And then to determine whether you have a growth or decay, you look at what's inside of the parentheses. So for the first one, you'd be looking at B. For the second one, you'd be looking at 1 plus or minus R. For the third one, you'd be looking at R. And what is that rule, you ask? So for growth functions, B must be bigger than 1. For decay functions, B must be between 0 and 1. And that's true for all of these. So for growth for the second equation, 1 plus or minus R would need to be bigger than 1. Well, of course, it would be the plus. The minus would not make any sense. And the decay would have to be 1 minus R, which that value needs to be between 0 and 1.